Okay, so welcome members. Today we are going to see now a very new topic, and it's a very nice topic for all mathematicians. This topic is called matrices. Please don't forget to subscribe to the channel. I wish you well. Now, here we see that we are going to start with the definition. We go into the common terms of used in matrices. We go through the types of matrices. We go through the algebra, and so on and so forth. So now we are going to start with the definition here. A matrix is a collection of information arranged or stored in rows and columns. First of all, you hear the word rows and columns. Here in matrices, you cannot avoid these words rows and columns. So common terms in matrices. Let us see the common terms in matrices. An entry. These are elements within a matrix. They can be letters or figures. So anything within a matrix, those are called entries. Then row of a matrix. These are arrays or lines of entries running from left to right. I have an example here. You see this one is running from left to right or right to left. As long as you have that, you see that the entries now, this is an entry, this is an entry, an entry, an entry. So a line that contains this was running from left to right is called a row. So this is the run, this is the row. So two of these ones are rows. Then when you come here, a column, these are lines with entries running from up to the bottom. So you see here, these ones are running from up to the bottom. So or from up to the down side. So these ones, now this is a column and this is a column. So those things that run downwards are called columns. These are still entries. Then order of a matrix. These are numbers of rows and columns of a given matrix. And order of a matrix is given by row times, this is called row by column. So this time is by columns. Like you see in the menstruation where we say length times width, we say length by this. So this is row by column. So here, for an example here, this one is having two rows. We start with the rows, then columns. This one has two rows. So it means that it has two rows. First we start with rows, then by how many columns? 1, 2 columns. So that's how we get the order, like you see there. Then major diagonal, a major diagonal. This is a line of entries running from the top left corner of a matrix to its right bottom corner. From the top left corner to its right bottom corner. So from here, running from here like this is what we call a major diagonal. Then the minor diagonal is a line of entries running from the top right corner. Now it's running from the top right corner, this is the right. Top right corner to the left bottom corner of a matrix. You see from here up to here. So this one is what we call a minor diagonal. Of course, this one is ordered too because we have two rows and two columns. We are going to see different orders, don't worry. Then types of matrices, we have a row matrix, like you know the one row. A row, this means that a matrix with only one row. You see that this one is only one row. From left to right is one row. So it's order. Remember, orders are given by row by matrix, row by column. So one row, how many columns? 1, 2, 3. One row, 3 columns. Then a column matrix, a matrix with only one column. So this one is having only one column. So instead we give its order row by column. So how many rows? 1, 2, 3. So 3 by is only one column. There. Then a zero matrix, a matrix whose entries are all zeros. I think we see all entries are zeros. All elements in it are zeros. Then equal matrices. Matrices are said to be equal if and only if. Okay, I need to put if and only if. Okay, anyway. If their corresponding entries are equal. So if A given by this and B given by this, if A is equal to B, it means that their corresponding entries are equal. So the first entry here will will be equal to the first entry in this matrix, as you see, A is equal to 1. The second entry will be equal to the second entry this side, like you see. Then this will be equal to this, and this is equal to this. Those are what we call corresponding entries. So this happens if by the matrices of the same order. Other than that, can happen. A square matrix, a matrix with an equal number of rows and columns. So here, if rows are equal to the number of columns, that is what we call a square matrix. You see this one where we have 2 by 2, 4 by 4, 3 by 3, all those are equal. Square matrices. You see this one, 2 rows, 2 columns. So that is a square matrix. We look at this one, 1, 2, 3, 3 columns. 1, 2, 3 rows. That's also a square matrix. When we come now to an identity matrix, a square matrix, of course, a square now what it is, whose only with only one in a major diagonal. I think we name major diagonal from the left to the right bottom is 1 and zeros elsewhere. So this matrix is said to be identity if it has a 1 in a major diagonal. I think we see 1 in the major diagonal. Then the zeros elsewhere. You see this one, the major diagonal is this 1, 1, 1. Then the zeros elsewhere. That's what we call an identity matrix, and in most cases is denoted by letter I. So that's it, members. Now we are going to see an algebra of a matrix in the next lesson. I wish you the best.